Alright, let's talk about one of my favorite things, magnificent, mind-bending engineering. I want you to picture something. You're looking at the B-2 Spirit bomber. It's this incredible, otherworldly flying wing, like something from a sci-fi movie. It costs over $1 billion. Its entire reason for being is to be invisible, to slip through enemy defenses like a ghost. And yet, as it comes in for a landing, you see something odd. The wheels are just hanging out. They're not tucked away in some super secret sleek compartment, they're just there. This makes my builder brain itch. Why would a machine designed for ultimate stealth have its landing gear exposed for all the world to see? This isn't just a small detail, it's a glaring contradiction. The plane is coated in radar-absorbent materials, its engines are buried deep inside the body to hide their heat. Every single line, every curve is meticulously designed to defeat radar. So when you see those bulky wheels and the doors that cover them, it feels like finding a screen door on a submarine. It doesn't seem to fit the mission profile. It's a puzzle, a genuine engineering mystery. On a project where every square inch is optimized for invisibility, this looks like a massive oversight. But here's a spoiler, in engineering at this level, there are no oversights, only trade-offs. So, my question is, what is the truth behind those mysterious wheels? This is more than a question about landing gear, it's a gateway to understanding compromises and the sheer genius that builds the B-2. Before we can get to the wheels, you have to appreciate the machine they're attached to. The B-2 Spirit is not just an airplane, it's a statement. Its shape is the first thing that hits you. It's a flying wing, a design that looks like it flew right off the pages of a 1950s pulp sci-fi magazine. There's no distinct fuselage, no tail fins, no real body in the traditional sense. It's just one smooth, boomerang-like shape, spanning 172 feet from wingtip to wingtip. That's wider than a Boeing 757 is long. This unique shape is the very heart of its stealth capability. Sharp edges and vertical surfaces act like mirrors for radar waves. The B-2's smooth, blended curves scatter those waves, making it hard to detect. Its mission is as futuristic as its look. The B-2 is a heavy strategic bomber. Its job, travel long distances deep into heavily defended enemy territory without being seen. It's designed to be a ghost, deliver its payload and be gone. To do this, it employs a whole suite of stealth technologies. Special coatings absorb radar energy. Engines are buried deep within the wing to hide heat signatures. A flight path computer helps it fly in the shadows of radar networks. It's the ultimate expression of low observable technology. This aircraft is a marvel of material science and aeronautical engineering. The skin isn't aluminum, it's complex composite, strong and radar absorbent. Leading edges must be perfectly smooth, no gaps or seams. Even the screws on access panels are special. They sit perfectly flush. Let's take a step back. Think about almost every other airplane you've ever seen, from a tiny Cessna to a massive Airbus A380. What do they do with their wheels after takeoff? They tuck them away. This is called retractable landing gear, and it's been a standard feature on most aircraft for the better part of a century. The reasons for this are pretty straightforward. One word: drag. When a plane is flying, it's constantly pushing its way through the air. Anything sticking out from its smooth surfaces, like wheels, struts, landing gear doors, creates resistance. This resistance, or drag, is the enemy of speed and efficiency. It's like trying to run a sprint while holding a giant open umbrella. By retracting the landing gear into the wings or fuselage, you create a much smoother, more aerodynamic shape. This immediately reduces drag, which has a cascade of positive effects. The engines don't have to work as hard to maintain speed, which means the plane burns less fuel. Less fuel burn means the plane can fly farther, or carry more weight, or fly faster. For commercial airliners, that equals lower operating costs and cheaper tickets. For military jets, it means longer combat range, higher top speeds, and better maneuverability, all critical advantages in a dogfight or on a mission. So, hiding the wheels is not just for looks, it's a fundamental principle of efficient aircraft design. Think about a fighter jet like an F-22 Raptor, another stealth aircraft. Its landing gear disappears into the fuselage with incredible precision. The doors that cover the gear fit so perfectly that they become part of the jet's smooth, radar-evading skin. This is why the B-2's situation is so peculiar. Here's where we get to the heart of the B-2's engineering puzzle. The problem isn't that the designers didn't want to hide the landing gear more effectively. The problem is, where could they possibly put it? Look at that flying wing design again. It's incredibly wide, it's also incredibly thin. Conventional aircraft have a deep, voluminous fuselage. They also have thick wing roots near the body. The B-2 is, for lack of a better term, a giant flat pancake. That shape is brilliant for stealth but creates a headache when stowing bulky components like engines, bomb bays, the landing gear. There's just no deep space to tuck anything into. Think of a conventional bomber like the B-52 with a massive fuselage for gear, or a Boeing 747 with a huge belly and thick wings that hide gear. The B-2 has none of that. Its wing must support over 330,000 pounds, yet it must stay thin for stealth and aerodynamics. The main landing gear is a massive four-wheel bogie like an airliner's. That's a lot of hardware to hide. Trying to fit that into the thin wing is like putting a bowling ball in a pizza box. It's just not going to happen. This lack of internal volume is a fundamental flying wing constraint. Every cubic inch inside the wing was prime real estate. The solution was a compromise. They designed bays just deep enough to house the gear, but the bay doors became large, bulging fairings on the underside. So this brings us to a concept I like to call the stealth tax. In engineering, every design choice comes with a cost, a trade-off. When you optimize for one characteristic, you almost always have to make a sacrifice somewhere else. With stealth aircraft, the primary goal is minimizing the radar cross-section, or RCS. Achieving a low RCS requires very specific shapes, smooth curves, blended surfaces, and an absence of right angles. The B-2's flying wing is the pinnacle of this philosophy, but, this shape is not necessarily the best for aerodynamic structural efficiency stowing components. The tax is the penalty you pay in these other areas to achieve that prized invisibility. The B-2's landing gear is a perfect example of paying this tax. If you compare the B-2 to another bomber, the B-1B Lancer, you can really see the difference. The B-1B is a swing-wing bomber, designed for high-speed, low-altitude penetration. It's fast and powerful, but it's not a true stealth aircraft like the B-2. When you look at the B-1B, you see a conventional fuselage tail structure. This design gives its engineers plenty of deep internal space to work with. Its landing gear retracts cleanly into the fuselage, covered by doors that fit snugly against the body. This creates a very slick, aerodynamic profile that helps it achieve its high speeds. The B-1B's designers didn't have to pay the same stealth tax as the B-2's team, so they could prioritize speed and structural layout in a more conventional way. Now look at the F-22 Raptor, its stealthy successor. The F-22 had to pay the stealth tax. The B-2's designers simply had to pay the highest tax of all. Building a machine like the B-2 is kind of like conducting a symphony of compromise. A room full of engineers and designers, aerodynamics, structures, propulsion materials, avionics. The aerodynamics expert wants the smoothest possible shape. The structures expert wants thick, strong spars. The propulsion expert wants big air intakes. The stealth expert wants to hide everything. All of these desires clash. Lead designers act as the conductor. They balance competing requirements to make the aircraft work. Imagine an all-terrain vehicle, huge rugged tires for off-roading, great gas mileage on the highway, as fast as a sports car. Knobby tires create drag and noise on the highway, killing fuel economy and top speed. A sleek, low-profile body is ruined on rocky trails. Every choice is a trade-off. The final design is a compromise, the best overall balance. This is what happened with the B-2's landing gear. The compromise was struck. The landing gear would be mounted below the main wing spar. That preserved the wing's structural integrity. It's one thing to design a plane on a computer, but it's a whole other thing to actually fly and land it. I've heard stories from test pilots who worked on the B-2 program, and honestly, they paint a pretty fascinating picture. Flying the B-2 is, by all accounts, a really strange experience. Because it has no tail, it just doesn't fly like a conventional aircraft. All the control comes from a complex system of flight computers that manipulate a series of flaps and spoilers along the trailing edge of the wing, a system called fly-by-wire. The pilot's inputs are really just suggestions to the computer, which then figures out how to make the plane do what the pilot wants, without stalling or losing control. It's incredibly stable, but pilots have said it feels more like guiding a UFO than flying a plane. Landing the B-2 brings its own unique set of challenges, especially because of that very landing gear we've been talking about. The main gear is set very far apart to give a stable base for such a wide aircraft, but the pilot sits way ahead of the main wheels. This creates a geometric challenge during landing, especially in a crosswind. When the pilot uses the rudder pedals to align the nose with the runway, the rest of the plane crabs or pivots around a point far behind them. One test pilot described it as feeling like you're trying to steer a bus from a seat mounted on the front bumper. It really requires a delicate touch. So what's the big takeaway from all of this? What does the B-2's landing gear really teach us about building incredible things? For me, the most important lesson is that engineering at the highest level is rarely about achieving perfection. It's about achieving the best possible outcome within a given set of constraints. The perfect solution, a completely invisible landing gear system, was just physically impossible without ruining the B-2's primary advantage, its flying wing shape. The designers didn't just throw their hands up in defeat, instead they found the next best thing. They engineered a brilliant compromise that protected the aircraft's structure and minimized the impact on its stealth signature. That's not failure, that's genius. Honestly, this principle applies to every complex project. A stealth bomber, a Mars rover, a build in my own workshop. You always start with an ideal vision, but reality inevitably intervenes. Materials have limits. Budgets have limits. The laws of physics are non-negotiable. The true art of engineering is navigating those limitations. It's about understanding which requirements are absolutely sacred and which ones have room for flexibility. For the B-2, the flying wing shape and its structural integrity were sacred. The perfectly flush underside was, in the end, something they could compromise on, as long as they did it intelligently. The B-2's wheels also remind us that even the most futuristic technology is still grounded in practical reality. This billion-dollar ghost still needs to touch down on a physical runway. It needs robust, reliable wheels and tires that can handle immense weight and stress. It needs hydraulic systems that will deploy the gear every single time, without fail. The most advanced part of the aircraft is utterly dependent on one of the most basic parts of aviation technology. It's a beautiful intersection of the cutting edge and the tried and true. The designers couldn't reinvent the wheel, so they focused on integrating it as cleverly as possible into their radical design. In the end, we come back to where we started, that nagging question about the B-2's wheels. And the answer is beautifully complex. The wheels aren't there from oversight. They are a deliberate, calculated, honestly brilliant piece of engineering compromise. The price of admission for a pure flying wing design. Designers prioritized the stealth profile. They prioritized structural soundness over a perfectly smooth underside, a small imperfection to enable groundbreaking perfection elsewhere. This defines great engineering. Imperfect perfection shows up everywhere. Space shuttle, fragile thermal tiles hard to maintain, but the tiles were the best fix for surviving re-entry. Formula One, odd wings and fins create huge drag. That drag gives the downforce needed to corner insanely fast. Out of context, it looks wrong. In context, it makes sense. The B-2's landing gear fits this pattern. Its weirdness equals genius. Next time you see a B-2 landing photo, see it differently. Don't just see a stealth bomber, see incredible stories, see solved problems. They're a central chapter, proof of human ingenuity. That's the inspiring part. But embracing compromises and clever solutions creates revolution. They're a visible badge of real-world engineering.